This is a solution to FRQ 4 of 2024 AP Precalculus exam. This is no calculator, so let's get started. Question part A says that the function g and h are defined by this. So we can see that g is an exponential function while h is an inverse sine function. Solve for gx is equal to 10 for all values of x in the domain of g. All right. So all we need to do is equate gx to 10 and sub in g, which is e raised to x plus 3 is equal to 10. I need to get the value of x, so obviously I need to drop this x from, from the first floor to the ground floor, and the method to do that is taking natural log both the sides. So once we take a natural log on both the sides, that's going to look like this. And now, as per the properties of log, x plus 3 is just going to drop outside, and we are left with natural log of e is equal to natural log of 10. What is the natural log of e, guys? That's 1. So that has no relevance here, and all I have to do is subtract 3 both the sides. So x will be natural log of 10 minus 3. So that is the final answer. This is no calc, so we cannot really solve any further. Question number part 2 rather asks about hx is equal to pi over 4 for all x in the domain of h. Okay, so I'm given arc sine or sine inverse. In fact, I can write this a step first, that hx is equal to pi over 4. And now I'm going to say that h of x, which is a sine inverse x over 2, is equal to pi over 4. And what should I do next? I can take sine both the sides, and I know that sine of sine inverse x, I will just write this a step over here. Sine of sine inverse x over 2 is sine of pi over 4, and sine of sine inverse x is x over 2, and this is equal to sine of pi over 4, guys, unit circle. What is sine of pi over 4? That is 1 over, or perhaps root 2 over 2. Multiplying 2 both the sides, so this 2 and 2 is gone. So I'm left with the final value of x as square root of 2, and looks like this is the only value which I'm getting. So this is all about part A. Let's move on to part B. We are given two functions j and k, logarithmic and trigonometric. We need to write j as a single log with a base of 10 without any negative exponents in any part of the expression, and result should be of the form of log of something with base of 10. So I'm going to do that. Part 1, j of x, let's read out the question first. That would be log of 8x raised to 5 with a base of 10 plus log 2x squared, once again with a base of 10, and then minus log x with a base 9 log x with a base of 10. I do see a property here, right? Because these two can be condensed by using the log a plus log b property, which is log of a times b. So a times b means the first term, which is 8x raised to 5, times the second term, which is 2x squared, minus, and I think I can use a property over here as well, kind of the reverse engineering what we did in the in the previous part. We know that this 9 can be moved on the top, just like the anything on the power can be moved outside. So I'm just going to reverse engineer this and write this as log of x raised to 9 with a base of 10. I'm just going to simplify this thing over here. So this is log with base 10 of 8 times 2 is 16, and x raised to 5 times x squared is, as per the properties of exponents, the powers are going to add. So 5 plus 2 is 7. So I'm just going to write 7 here, and that remains as it is. And finally, log a minus log b is log of a over b, right? So log of the first term, which is 16x raised to 7 over x raised to 9. But there's more to it because we can simplify this further. So I'm gonna say that the powers of x will cancel, right? So it will become x raised to 7 over x raised to 9 means 9 over 9 minus 7, which is just 2. And I think this is it because they don't need any negative exponents. Otherwise, I would have written this as x raised to minus 2 on the top. But I think this is what they need. So I'm just going to box it up. And this is my final answer over here. All right, let's move on to part 2. Part 2 is asking to write k as a single tan function, a single term rather, single term involving tan x. We can do that. Kx is equal to 1 minus sine square x over sine x times secant of x. What is 1 minus sine square x, guys? I think as per the Pythagorean identity, 1 minus sine square can be written as cos square x over sine x. And what is secant? Isn't secant the reciprocal of cos? So can I write it as 1 over cos? And what is cos square over cos? Obviously, one of the cos is gone, and I'm left with cos x over sine x. Cos over sine using the quotient identity is nothing but cot x, but they need the answer in terms of tan x, and we know that as per the reciprocal identities, cot x is nothing but 1 over tan x. So I'm just going to box it up, and I think this is the final answer because this is what they needed, right? They just needed in terms of the single tan function. Finally, the last question which we have is part C, where they are saying where they're asking to find all the values in the domain of M that yields an output of 0. So M should be 0. Let's try to do that. Mx should be 0, which means that cos inverse tan of 2x should be equal to 0. Let's take cos both the sides. So I'm left with cos of cos inverse tan of 2x is equal to cos of 0. Cos of cos inverse something is just that something, right? So cos and cos inverse are kind of cancelled. So we are left with tan of 2x is equal to cos of 0, which is just 1. And I think we can solve this, right? This is a usual trigonometric equation. For tan, we know that tan is equal to 1, and since the period of tan is pi, we just look for a single angle between quadrant 1 and quadrant 1 and 2, where tan is 1. And I know that tan is 1 and pi over 4. So I'm going to say that 2x is equal to pi over 4, but they are looking for a generalized answer. So we are going to add an n pi to it because, again, we are looking for a generalized answer. Okay, but keep in mind that this should be in the domain of M. I'll talk about it. I'll talk about it. So I'm going to divide both sides with 2 over here because that is what I need to isolate x after all. So dividing both sides with 2, I will get x is equal to pi over 8 plus n pi over 2 and pi over 2. And I think this is the answer. Now, if you want to recheck about whether this is in the domain of M or not, we know that the domain of cos, as in this inside thing, should always be between minus 1 and 1. So I want tan of 2x to be always between minus 1 and 1. And yes, it is indeed always equal to 1 because that's what we are solving for, right? So all the solutions from here are allowed. I'm just going to say that n is an integer. N is an integer over here, and all the solutions from this particular box are allowed. So this is, we have infinite solutions and all, depending on the value of n, everything is in the domain of n. So that's it for the solution. I hope you got it correct, and I'll see you in the next video.